We will be starting with the lightning pitch competition, and to be overseeing this, I'd like to invite Thomas Andrew Olson to the stage from Exodus Consulting. He will be giving you an overall description as well as what we'll be hearing from this morning for the lightning pitch.
Find my glasses so I can do this right. Good morning, everyone. Welcome to Lightning Pitches. This is something new that we've done through the auspices, of course, the NewSpace Business Plan Competition and the Space Frontier Foundation and a lot of our great sponsors. Today is a very short format kind of event. We have 3 great judges who I'll introduce in a minute. We have 7 great presenting teams. They're going to get 4 minutes to do their slideshow and do their pitch, followed by 4 minutes of Q&A from the judges. And a decision will be made later this afternoon. And there is some prize money on the line, of course, a total of $30,000 in prizes, courtesy of our sponsors at ATK. I'll be introducing them again in a moment. Before we get started, there's a lot of people we need to thank who made this thing happen. It's been a really great process going forward. We only started this in early May, and now here we are. Firstly, I want to give special thanks to our contributing sponsors. These are the people that went out and pitched this event and marketed the event and went out to their personal networks and got people to attend. And we got a lot of investors in the room today as a result of a lot of the people that were involved. First off, our contributing sponsor, NewSpace Global. I don't know if Richard David's here today, but thank you so much for your help. And of course, the amazing student team at the Stanford Student Space Initiative. Now, I met these folks last year, and we worked with them for the BPC at Stanford, and I've never seen a more dedicated and a very well-connected group of people in Silicon Valley. Henning, are you here? Henning Riddell? Okay, well, I want to give a shout out to SSSI, so thanks so much for your support. And of course, I just got the notice, I have a big announcement right now. Our other contributing sponsor is the Space Angels Network. They're a really dedicated group of guys doing angel investing in and around the space arena. And one of our judges, who is a part of SAN, asked me to make a special announcement today, is in that SAN has made an offer to the winner of our competition today, not only for a one-on-one session with one of Space Angel Network investors, but they're also going to be invited to pitch to their upcoming investor retreat in September. So thank you, Space Angels Network, for that great gift and that great prize. Thank you so much. I also want to really talk about the other sponsors we have here today. One of the sponsors who've been sponsoring the business plan competition in particular, and this event especially, the Highline Prize Trust has been an early adopter of what we do, and they've given us very strong, solid support for many years. Art Dula and Bugner Hightower, I know, are here today, so get a chance to say hello to them. You'll be hearing a lot from Art this afternoon. He's on the prizes panel, and he's giving a keynote address this afternoon, so be sure and catch that. Thank you so much, Highline Prize Trust. And of course, I've saved the big guns for last year. This organization is the first ever private corporate sponsor that the Business Plan Competition Group has had since we've started this adventure a number of years ago. They sponsored the second place prize of $25,000 last year's BPC, and plus a $5,000 market sector prize for the best entry in the field of on-orbit servicing. They stayed with us this year, and I hope they'll stay with us next year, and you'll be hearing from them a lot more this weekend as well. Please give thanks to ATK. Jim Armour, you here? Arnie Streeland. If you can like just stand up a little bit, make yourselves seen. Thank you, Jim, so much. They've put up $30,000 in prizes today, and did a lot of great program support. And you'll be hearing from Jim at lunch today. He'll be our designated luncheon speaker, and you'll get a chance to see me again and as I introduce him. So And of course, nothing goes without the dedicated teamwork right here at the Space Frontier Foundation and the team that put this on. And I really have to give special thanks to someone who not only helped handle a lot of the logistics for the entry process, but also took it upon herself to reach out to the contestants after they were selected and help them refine their executive summaries even further. And then also took it upon herself to organize a special day yesterday afternoon. It went from about noon till 6:30, I guess it was, where they refined and honed their pitches themselves. And actually, I got to see the result late in the day. Jeff Feige and I got to sit down and pretend to be the Sharks for a little bit while they did their final pitches, and I was pretty amazed at the result. They did a great job. Please give a big, big thank you to Megan Crawford, our communications director. Marvelous, marvelous woman. And of course, the one person who I always enjoy having at this conference, and he's a great, great help he's a logistics master. Couldn't do this without him. He's the master timekeeper. He puts things in my hand that I didn't know I needed at the time, but I looked at it and go, oh yeah, thank you. That's the kind of guy he is. He anticipates and he makes things happen, and he's my left-hand man. Please welcome and thank Joe Venius. Okay. This is more of a Shark Tank style event today, where again, as I've said, the contestants will get a chance to deliver their pitch in about 4 minutes, and the judges will get a chance to fire back Q&A for about another 4 minutes, and then it's on to the next one until we're finished. Again, the money that's on the line today for these guys are applying for is a $20,000 first prize, a $7,500 second prize, and a $2,500 third prize, again, courtesy of our sponsors at ATK. Now, let me introduce to you the judges. First up is Steve Goldberg. This is Dr. Steve Goldberg from Venrock Capital. He joined Venrock in 2009 after having been CEO of several early-stage companies, including Data Runway, ArcWave, and CoWave Networks. Not a lot of lighting here. I'm sorry about that. Prior to that, he was Vice President of Research and Development at Nokia Internet Communications and Vice President and General Manager of Wireless Communications Division at Silent Corporation. He received his BS and MS in Electrical Engineering from Washington University and his PhD in Electrical Engineering from the University of California, Santa Barbara. From Venrock Capital, welcome Steve Goldberg. Next up is Brad Fleury. He's one of the senior members of Edge Consulting. He's a senior marketing and business development communications executive with over 12 years experience in the aerospace industry, including systems engineering, management, and business development. He possesses leadership ability to develop and direct successful marketing communications plans, develop sales strategies, and business capture activities. Please welcome Brad Fleury. And finally, a good representative of our Space Angels Network, and the one who gave me the great news today about what SAN is going to be doing for one of our fortunate winners today. Amaresh Kalapara is the CEO of the USA Division of Earth to Orbit, Inc., and a principal of the Space Angels Network. He serves as a management consultant and financial advisor to a generation of space entrepreneurs by helping them develop valuable businesses and navigate the world of venture finance. He co-produced the first and second annual Space Venturing Forum, an entrepreneurial event hosted by the National Space Society. In a related capacity, he's on the executive committee of the Space Investment Summit Coalition, which is a group of organizations focused on developing interaction between the investment community and entrepreneurial efforts in aerospace. He often speaks at aerospace conferences on topics related to business and economics of the commercial space industry. Please welcome Amaresh Kalapara. All right, the Sharks are ready. Are we ready to throw some chum in the water? I'm going to start right out with introducing. I'm going to be introducing the pitching teams in alphabetical order, just to be fair. Joel will be keeping the time very strictly on their presentations as soon as we cue them up. The timekeeping starts the moment you start speaking. And it's T-minus 4 minutes from there. So are you ready? Come on up, Cube Cab.
Okay, let's get that up. Hi, I'm Adrian, this is Dustin. We would like to tell you about CubeCab. We take CubeSats to low Earth orbit one at a time. Currently, CubeSats are kind of second-class satellites. To get into orbit at all, you have to attach to a primary payload, we call that the truck model, or you have to go with a bunch of satellites, we call that the bus model. Either way can take years, you have to go where the rocket goes, there's a bunch of other problems. Even with that, about 100 CubeSats were launched last year, and the expectation is 300 to 400 in a couple years. So the CubeCab service, we launch one CubeSat at a time. Our design mission is a 1U or 3U to low Earth orbit, obviously to 500 kilometers polar, obviously different rockets for those two models. We air launch, you cannot get a ground pad cheap enough for our price, we go with standard market prices. We operate faster, we operate better, so we can get a lot more people who currently don't even think CubeSats are within their complexity budget to become customers. Since we are going to be doing 10 to 100s, we can do a high flight rate, which has not been possible before. Previously, you were lucky if you could do 6 launches a year. We're tending to do 10s to 100s. So it means you can do mass production, you can automate the process, we can partner with vendors, and generally, our advantage is the combination of the market is here and we have access to all these technologies. Here's a little illustration of what air launch means. We do not launch from ground pads. And here is a brief overview of some of our core technologies. The key point is at the bottom. We do commercial off the shelf, not mil-spec. Now, all these technologies are things that our competitors could get access to. None of them have access to the specific combination. By the time they could get access to them, the markets were probably going to be moving on, thus our main advantage. And here's the competitive advantages. Currently, you could take sounding rockets or balloons up. You could get some of the advantages of orbit, but not really. You can go with a truck or bus model. They're slower. If any of the other guys backs out with the payload, then the entire flight's in jeopardy, so your payload might not be able to go up. And then there's us. Oh, and also we can do constellations of CubeSats, putting each CubeSat into its appropriate orbital slot one at a time. You cannot do that currently. So our financials. Standard model, we get the investment, we do our R&D, and then sales kick in. Investment plan, here's a brief overview of how much we need at what stage. Kickstarter towards the end, more to generate publicity than to actually raise funding, which gets into our marketing outreach. NASA CubeSat Launch Initiative, how big of a backlog do they have? We can just take it and service it. We can do direct outreach to universities and corporations. And then once we've got a few missions under our belt, civil and military space can start coming to us on a commercial off-the-shelf basis. It's about the same amount of paperwork it would take to fly an airline ticket on a government dime. So this is the team. This is just the team that's here today. We got a bigger team than just this, but we figured just list the people who are here today. Thank you. Any questions?
Hello. Thank you. Great presentation. How much will it cost to develop your launch vehicle?
Roughly $5 million plus another couple million runways for profitability, roughly.
Can you guys just say a few things about competitors? I know there's been a couple of companies that have attempted this air launch scheme in the past.
So there's competitors who do air launch. And then there are very few competitors who try to do individual CubeSat launches. So far, there hasn't really been a combination of them. The people who've been trying to do individual launches have mostly been ground launch, and they found the cost of a ground pad alone kicks their per flight price up.
And I've got one short one. So do you think this is a winner takes all, that if you find a solution that's effective and cost effective, that the other solutions will just go away? Or do you think the truck model will be attractive to some companies and yours will be attractive to others?
Oh, we certainly believe the truck model will continue to be attractive to some, especially if, say, you want to launch 10 CubeSats to the same orbit. Well, that's the bus model right there. We're not going to be a be-all, take-all, but we are going to grow the market a lot beyond what currently is considered to be the CubeSat market. Anything else?
One last question if we have time.
Give me one
So,
for Austin.
can you talk about your customer base? You mentioned the numbers of CubeSats that are expected to be launched over the next few years. Do you envision your customers to be more universities or more commercial companies or government?
We suspect, especially at first, our customers will mainly be university and commercial. Again, government, we're expecting to come to us on a cost basis. We specifically are trying to avoid having to apply for any government grants. We are not a grant shop. We want to avoid the cost of doing that kind of application. So, which will reduce the number of government customers. On the other hand, eventually, once we are proven out, they can come to us. There still won't probably be as many as university and commercial, though. That all? Okay.
Next up is Cubersation. Again, same thing. Clock starts as soon as you speak.
Good morning and welcome. My name is Jose Molina, and joining me is Lilia, and we represent the Cubersation team. So what is Cubersation? Well, we provide ground segment services to small site operators. The problem we aim to solve is the lack of this service. We plan to buy and install a network of ground segment stations and to enable our customers to connect to their satellites, to communicate with the satellites anywhere, anytime, using a software that we're currently developing. Sorry. So currently, we have an agreement with ISU to use their ground station for testing our system, and we look forward to collaborate with other universities to expand our network. So why are we in this business? Basically, there's an increase of small cell deployment, and by year 5, we plan to capture 20% of the market. So the market is growing, there's customers, and there's competition. The first two you see there, they're vertically integrated, meaning they own their satellites and the ground stations. For example, SES for the giants, and Planet Labs as for the startups. So basically, they're self-operated. And we have military and universities competition, but those are non-commercial. So our product is a software that will enable the customers to connect with the satellites from anywhere, anytime. And our services is our global communications and satellite health monitoring. So for the first stage funding, we're seeking $250K for the development and testing of the software, and the due diligence for the establishment of the company. So here's a breakout of the expenses. So mostly about 62% is going to be used for the software development and operations. For stage 2, we seek $3.8 million for the continuing of the development and testing of the software, and we're going to buy and install the first ground stations around the world. So basically, the business model is tire-based charges, one-time fee plus a monthly fee, and the exit strategy is merger and acquisition. By year 1, we plan to capture 4% of the market. By year 2, be profitable. By year 3 and 4, we'll break even, and by year 5, we're going to have 7 million plus of revenues. So why us? We are an international team with 15 plus years of experience in this sector, and we're well connected through the ISU Global Network. Our advisor is Dr. Walter Peters, the president of ISU. So in conclusion, there's a great opportunity. The idea is a software for customers that will enable customers to connect to their satellites anywhere, anytime. There's a market demand. The strategy is to develop and test the software, install the ground segment, and have 20% of the market by year 5. We're seeking 20K for the for first stage, and we know there's some challenges. So thank you very much. Any questions?
So, no need for a real long answer here. It's kind of a technical question, but I'm assuming there's no standard protocol here. So you've got physical layer and kind of data link layer. Do you have to have some sort of an upfront NRE agreement with each satellite company, and then you basically design some sort of software-defined radio for each system, and then go from there? How does that work?
So we're not looking into the protocol. Each company will own that. You know, they will provide the communications service only.
So do they have to provide you with the receivers? I mean, how do you actually?
I'm not the technical person here, so I'm not the one to ask. So okay. Yeah, I don't know.
Can you say a few more things about your licensing and permit requirements?
Sure. For licensing, we gotta get broadcasting licensing from all the countries that we plan to establish, but then the customer has to get their own licensing for broadcasting down, for downlink. Yeah, for the spectrum, basically.
Can you talk a little bit about how the market works today? So is the main obstacle today the number of ground stations, or is it the obstacle the software protocol, or is the obstacle the cost of downlink? So if you were to describe very succinctly, what are the issues today that you address? What are they?
Well, basically, there's a lack of the service for this market. It's because the players right now, the big ones, you know, they're charging around $6,500 an hour. They cannot afford that. So that's one. But like, for example, Planet Labs, they can repurpose their stations to service this market if they wish to. So this could be a risk for us or an opportunity to collaborate with them.
Maybe you can say a few things about your first few customers. You know, what would that sweet spot of a customer look like?
Well, first of all, we gotta test our system. So our first customers are gonna be the ones that they're gonna be with us since the beginning. So probably we haven't, you know, we have Planet Labs, Nano Satisfy, and you know, sorry about this. Let me look for it. Dara Aerospace, Planet Q, IQ, Geoptics. So it's just knock on the door, say, hey, what are your needs? Can we, work together?
Comment on how you actually would approach the partner ground stations. What is their incentive to sign up with you? Why wouldn't they sign up directly with these customers?
That's a good question. Well, I don't know. Anything else? Okay, thank you.
All right. Thank you.
Sorry.
Just really quickly. Okay. Next, make sure your slides are ready to go first. But next up will be Elysium Space. Again, the clock starts as soon as you start talking. So good luck.
Good morning, everyone. I'm Thomas, the founder of Elysium Space. I used to be a former NASA engineer, and most of you might think about technology when they think about space. We believe at Elysium Space that space has more values than that. It has some inherent values like beauty, which can be used to make exceptional memorial services. Funerals have been around since the age of time. I showed some funeral monuments. Actually, the first one is from 4000 BC. And still today, families need a very unique and meaningful experience to honor the memory of a loved one. Especially now, as we are transitioning over the last 50 years from funeral rituals to live celebration ceremonies. So it's important to have something more modern. It's a huge market. Think that we expect the baby boomers to spend $500 billion on funeral services. So we made this memorial spaceflight service. We basically give a small capsule to people where they can place a sample of cremated remains. We collect all the capsules that we place in a spacecraft, and then we launch the spacecraft into orbit. It orbits the Earth for several months. During that time, family and friends can track it and see this journey through the star using the app. Eventually, because of the atmospheric drag, it re-enters the Earth's atmosphere, burning up and blazing as a shooting star, which gives some poetic final experience. This is our spacecraft. It's basically a CubeSat, which can contain up to 500 capsules. Regarding the market, we focused on the two most interesting places for our service for economical and cultural reason. It's USA and Japan. You have 1 million of cremation in USA and another million in Japan. We launched our service last year in these two countries. Our business model is pretty simple. We charge $2,000 for the service, and we can have up to 500 capsules in a 1-unit CubeSat, which gives $1 million revenue. We spend about $100K for the launch, $50K to build the capsule and then the packaging. So you have an 85% gross margin. It's scalable. You can have 1U, 2U, 3U CubeSat, multiple CubeSat per launch, and eventually multiple launch per year, which allows us to start small and become bigger later. The distribution is both online and offline. We have a website, so people can directly book a memorial spaceflight. And we also have a referral partnership with funeral homes, so they can refer service to their existing customer, and we give them some reward in exchange. There is some competition. You probably know Celestis. They started like 15 years ago. They charge $5,000 for the same service, and they had about 600 participants so far. We're different. We are 60% more affordable, charging $2,000 for the service. We provide a state-of-the-art mobile app to have a better, experience and some beautiful, dignified packaging. But most importantly, we are designing a genuine memorial service. In our team, we have half of the team is from the funeral industry. We have a funeral marketing expert, 25 years experience in the industry. We have a world-class anthropologist from Harvard University. She basically wrote the reference book about it. So what's next? We're going to launch in some new countries. We want more local partner. First launch is this fall. We expect to have from 50 to 100 people. We are heading to the moon. It's an exceptional place, and we are raising 300K. Thank you very much.
I applaud you. We all know there's only a couple things that you can know for certain. One is death, and one is taxes, and one is death. Right?
That's right.
So this is a great business. Yeah, never going to go away. So the competitor looks like in 17 years did $3 million worth of revenue. So I was just kind of curious. You didn't kind of talk about this is a consumer play. So you're basically going to have marketing expenses. I mean, do you have a sense? You said your costs are going to be dramatically lower. They haven't done a lot of revenue, so I'm just going to sort of make a statement that the market really hasn't opened. I mean, it's not I wouldn't call it a particularly successful business, $3 million over 17 years. So what do you think it's going to take to sort of open the market for people to really, to be aware and to use the service?
So it's a pretty, long question. I think what is essential is to understand that actually Celestis has been mostly deploying a payload into orbit. It has not been providing a memorial service. After it's done, it's done. And people, as I was saying in the introduction, are looking for meaningful and unique experience. They are not looking to have just the ashes into orbit. So this is why, we have people from the funeral industry. Other questions that how do you reach the public? Visibility is key. And for that, we have been proactively looking for PR. We have been actually very successful. We have been featured in mainstream media over 300 times. So that's how we reach people. It's currently the most cost-efficient way to reach the public for us. Thank you.
Have you guys made any sales as of today?
Yeah. I was saying we expect to have 50 people because we are getting closer to 40 now. So it changes every week because, we are operational and we have new customers all the time.
Okay, so your competitor has sold 600 units. and
Over
you guys
15 years.
Over 15 years, and you guys have sold 50 units over?
In like 12 months.
Okay.
Actually less, I would say maybe 10 months.
Can you comment on your launch costs? So I saw on your slide you indicated $100,000 cost for launch. Where have you launched thus far, and where do you plan on launching at that rate?
So different option for the launch. This morning, some people were mentioning, you have nanoracks, so launch from ISS, which have some advantages. We are also looking at other one, space flight services offer launches from Vandenberg, military base as well with TIVAC. So we are working with all these brokers. This 100K price is average. It's lower if you use nanoracks. It could be a little bit higher if you use other launcher. This is where we are heading.
I don't know much about the funeral industry, but it seems to me you sort of take over once the cremation has occurred. So is the expectation that you'd partner with the funeral industry and then they offer, because the way it sort of works is, from my limited experience, is you're sort of faced with decisions, you check boxes and you say, I want this, 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 and this, and then you have your funeral. So are you guys working with the industry and it'll be extra
definitely.
service?
I will answer very quick because I'm told I have like 10 seconds, so we can talk after at the lunch.
Okay, sure.
We are not competitors, we are partners because it's a post-cremation service. So after they sold all their service, we can come and add this in the catalog like a new item, basically. This is it. Thank you.
All right, we're almost to the midpoint here, and let's welcome our next group of presenters at Hive Space Systems. And again, the clock starts when you do. So, okay, good luck.
Good morning, everyone. We are Hive Space System. I'm Anand, and my colleague Prasanna here. Let me explain you our business idea in a very simple manner. Imagine there are customers who have their packages and they want it to be delivered to particular location, but there has to be, I'm really sorry. But there has to be someone who makes big boxes, get those small packages together and send it to a location with the delivery vehicles. Same way, we want to manufacture big boxes to put small CubeSats in them and put on top of a rocket with the current launch providers being launching every day. And our customer base would be academic institutions and industry who are making a lot of CubeSats nowadays. And CubeSats have immense potential as a small satellite platform with academic researchers and with industrial applications. But the problem here is there are they take more than 2 years to be launched, and the launch cost is around more than $100,000, which is way higher what universities could afford. An opportunity we see here is every university has satellite labs. They have student building satellite every year. And currently, Google, Facebook, Planet Lab announced that they are launching more than 100 CubeSats a year. And we want to solve this by presenting our model. We want to make these boxes to be adaptable in empty volumes in current rockets. As everybody know, current launches don't go completely 100% full with their weight capacity. They have 80% full, 90% full. So we want to use that empty space and manufacture our product to be accommodated in that. Currently, we see as our competitors to be, they're not direct competitors. We have Cal Poly, we have Spaceflight. They are associated with one of the launch vehicles, which make them harder to launch more frequently and lower the cost below minimum threshold. And talking about cost, we are promising to go as low as $20,000, from $20,000 to $40,000. That makes it open to anyone who is from high school, industry personnel, academic institution. It will promote them to make more CubeSats, carry out more experimentations. And also, we collaborating with different launch providers make us eligible to commit about frequent launches, which is an important issue in CubeSat launch industry. Our sales strategy would be using our immense resource of academic connections we found out through sets, through conferences, and we want to go out to different trade shows, present our products. That would be, and firstly, we want to go to universities to present our plans and promote them that the cost is lower and you can launch more frequently. Our team consists of expertise with system engineer, with controls personnel, and with the business personnel. And we are currently looking for financial officer and a market representative. We also have backed up with the academic professors, and we are currently talking with some industry personnel. Our financials look like will be reaching to 1.3 million revenue by the end of first year and boosting it to be 14 million, which makes it to be around 7 to 10 times return on investor for our investors. And we are planning to get acquired in 4 to 5 years. Thank you very much.
Would you consider the P-Pod to be one of your direct competitors? And then if you do consider it to be a direct competitor, maybe you can talk about some of your advantages against the P-Pod or some of your other competitors.
I say no, P-Pod is not direct competitor to us because we are planning to put a lot of CubeSats together in big dispenser units. So we are also considering making our dispenser unit which can accommodate like 20, 30 P-Pods together. And in certain year, might be P-Pod would not be a standard for CubeSat packaging. So we are also considering that there will be direct CubeSat casings which we can package in our dispenser units.
So if you can expand on that, so how many CubeSats do you envision fitting in your system? And you said it'll be about $20,000 to $40,000 for your product. So is that just the physical hardware, or is that also an introduction to the launch vehicle? What part of the launch process is part of your product?
Currently, the $20,000 I committed is just a launch, and we have different modules like pre-launch cost, post-launch cost, and we want to take care of packing those CubeSats in our dispensing units because we have to design dispensing unit according to empty volume available. Our product will not be a fixed dimension because we are using an unused space in rocket. And regarding pre-launch services and post-launch communications, we right now don't have experience in that. So we want to outsource those needs of our customers. So that cost will just cover the launch services.
Let me just understand this. So you are going to partner or contract with the launch services, and you're going to build a product that more efficiently packs satellites into existing launch vehicles and launch systems. So are you just a product company that sells that efficient structure, or are you a services company where you contract with people who want to launch the who have satellites? And I'm a little confused. Are you a services company or a product company?
Actually, we plan to be a services company, but we do have our product. So basically, we will be tying up with different universities and different people who are making CubeSats, and then we'll try to get them a place on the rocket as soon as possible. So our product is obviously the dispenser in it, but basically we are service providers.
Thank you.
And for the $20,000 or $40,000 range, what is your cost for that?
We recently checked out a launch cost which Cal Poly established with Napier launch vehicles, and with PSLV being one of the major provider for CubeSat launches. And we saw their launch service cost is around $3,500 per kilogram, and for PSLV being $4,500 per kilogram. And that's why we commit 20,000, which is minimum, but that also we need that will be flexible depending on which orbit they want, where the launch vehicle is going.
And give us an idea of what the size range is for your product. Are we talking a few dozen 3-unit CubeSats up to a few hundred? What's the range of size?
Currently, the first conceptual design we created to be for around 24 CubeSats. So that will be 1U, and that has a capacity to accommodate 4 3Us, 4 2Us, and 4 1Us. So that's just a basic startup product, but that will vary according to volume available. If they have 80% volume available, we are ready to design according to that. And one thing I want to add is there is a simplicity in this technology that we need to design a big casings for empty volume. So we are not like trying to present a big technology, or we are just filling out the empty spaces. Thank you.
All right. Thank you. And just in case you've noticed by now, there is quite an international representation in our contestants today, just like there is with our conference as a whole. And I think it's a pretty amazing thing that space is kind of the glue that has brought a lot of people together around the world and has transcended international boundaries and political boundaries in particular. So I felt I needed to mention that today. Next up is a company called RockZip.
Good morning. Testing, testing. Test, test, test. Test, test. Yeah, there's a green light, number 3. Testing. Good morning, NewSpace. My name is Austin. With me today is Adam and Martin, and we are RockZip. We make high-altitude balloons. Now, we all know that you can go up to space on rockets, but tens of thousands of payloads are taken to space every year on high-altitude balloons. And we're going to take millions of people to the edge of space that otherwise could not get there because of the cost of rockets. Now, in particular, we are the Model T of the high balloon industry. We are going to drive innovation and automation into an industry that has a lot of manual labor currently. Now, the current market for the high balloon in the 6-pound and under category, we estimate it's $70 million today. We think this market is going to double within the next 3 years and be worth almost $500 million by 2020. Now, we know that Google right now is working on the Google Loon project to spread internet around the world on high-altitude balloons. They're going to need tens of thousands of balloons. Someone has to make these efficiently. And we also know that Kmont Balloons, one of the world's largest distributors of latex weather balloons, has had to take down the contact information on their site because of so much recent interest. Now, what are the customer pains? High prices. A lot of manual labor means it's going to be expensive. We know there's a low supply. In fact, even websites that have balloons often are out of stock and slow delivery. There's a complex launch of having delicate materials requiring several people trying to launch these balloons. And over 99% of these balloons are not reusable. So how is RockZip different? Well, we are the efficient manufacturer. We'll be low price, 50% savings on the same type of float balloons that we offer. We will have a constant supply. You order today, we'll ship it to you tomorrow. We'll have a simple launch. 1 or 2 people can launch a Rockzip balloon. They're very durable. You don't need special gloves. And we'll be focusing on reusability in the future so that these can be even cheaper per launch. So who are we targeting for sales? Weather and education markets we'll be reaching out to through the online retail as well as distributors who sell full balloon kits. And we'll be attacking the larger customers such as Google Loon, Telecom, maybe some of the smaller NASA launches through more of a customized direct sale approach. Currently, we're working a lot on our social media, public relations, both locally in Indiana and bringing it out nationally. And we are actually launching a Kickstarter in the next 2 to 3 weeks, which we hope all of you NewSpace will help support us. Some of our official partnerships, University of Michigan is helping us final test our balloons because education is one of our first markets to make sure that we're set up before we go into full commercialization. Spaceport America is now official partner because they're expecting over 200,000 visitors at their location, and not everyone can afford a ticket into suborbital. As well as the Challenger Learning Center. There are over 40 around the United States, and we'll be piloting with them next week for the first collaboration. As a competitive analysis, you will see that Rockzip, on terms of price, average float time, the launch team required, and ease of purchase, that we are definitely above our competitors, and we have carved out a beautiful niche in the under 6-pound payload market. We've put in $20,000 up to date. We're looking for $250,000 investment, which we expect an 15-time ROI by year 3, upwards to an 85 times ROI by year 5. Now is the time. The high balloon industry is exploding, enormous need for these balloons, and we own the intellectual property and are going to be flying these very soon. Thank you very much, and we'll tell you a little bit more about the team as we move forward. Thank you.
Just a quickie. So you didn't talk about the technology at all. I know you only had 4 minutes. So what is it about your balloons that you can sell them for half the price? You said they work better too, but why can you make them so much more cost effective?
Primarily through the automation. So we have a lot of patents that are currently pending of the way that we make them. We're taking hands away from the manufacturing process, and we're using slightly variation on materials, still proven in the aerospace industry, but different so that they can be done more by machinery and not hands.
In terms of your market, for the 6-pound and under that you guys are focusing on, just quantities, what does it look like today and then a couple years out into the future?
So if we focus on the 4 main markets we've been mentioning, the largest one and the most stable one is the meteorology or weather. That's already proven and stable and still growing. Then if we look at the K-12 STEM programs and telecom and loon projects, we see that today there are more than 300,000 weather balloons or high altitude balloons in the air. And we expect these rapid growth rates in most of the 4 core segments we're targeting, and we are planning on just getting a tiny piece of that is already going on, and we're confident that we're going to make it.
What altitude does your balloon fly at, and how long does it stay up?
Currently, we're aiming for around 65,000 feet just to get started. Right now, we've been flying prototypes that have given us a sense for what our design will be capable of doing, but right now ours fly at about half of that altitude, but we get the estimated float time that we're looking for.
Just one quick question. So it seems like the market is metrology. I mean, it's 50x anything else or more. And so is that the U.S. government? Is this global or is this U.S. only? And so is that the U.S. government? Does that mean your business wins and loses based on one customer?
Well, what's interesting is that there are over 800 balloons flown per year, or per day, just for meteorology. And there's about 200 in the US and about 600 around the world. And time doesn't matter, good economy, bad economy. Every day, twice a day, they launch balloons. So this is just something that has been historically, in order to get the weather predictions that we have. Oh, the customer is under NOAA, the National Weather Service in the United States. And then would be one customer for the daily launch, but then there are right now a lot of university researchers. Example would be I'm specifying a project in the ozone layer, and so they would get grants in order to focus on a different type of weather.
And you're looking to sell your balloons, it looks like for $200 a piece, and then what's your cost on those units?
This is for the weather market. It's a slightly smaller balloon because of very small payloads. So the cost on those, because this is all public, we're not specifying, but we're very driven when it comes to the automation, making sure that we have healthy margins to continue as a business.
Do you view UAVs that fly at that altitude, like Titan Aerospace, or sounding rockets as competitors?
I think that for some applications, yes. I think anything that goes up to that altitude could definitely be a competitor, especially once you start getting into really long duration flights. Google, they just bought some UAV companies, Tech Aerospace. So the difference is that we're targeting right now the small consumer type market under 6-pound payload. But yes, they're definitely competitors.
What is the...
Thank you, everybody.
This one's not working, is that the deal? What's going on with this one? Here. That back, whoever might want it. Okay. All right, thank you, Rockzip. Next up, Space Resources Extraction Technology. I said, the moment you start talking, you may start the clock. Okay.
Good morning. My name is Ed Etheridge. I'm the founder of Space Resources Extraction Technology. We're in Huntsville, Alabama, and we will microwave the moon to extract water. The problem is the high cost of Earth launches at $10,000 a kilogram. To land payloads on Mars and the moon is much more expensive, $100,000 versus $1 million per kilogram. But the solution is, let's not launch so much mass. Let's use in-space resources. We subscribe to the Vegas principle, Las Vegas principle. What's mined in space stays in space. Back in 2009, the LCROSS spacecraft crashed into the South Pole of the moon and proved that there are billions of tons of water at the lunar poles. This water will be used for habitation. It will be used to produce in-space rocket propellant, and water is an excellent radiation protection material. Water is the low-hanging fruit of space resources. There are large potential markets. A manned lunar outpost will require a ton of water and a ton of oxygen a year for a $200 million market. To land and ascent back off the moon would require 11 tons according to the Apollo model. That's nearly $1 billion just for the propellant. There are 400 or more communication satellites. At the end of their life, they run out of propellant. The market for refueling these satellites would be $50 million. And we have identified some Earth applications with significant markets that we could do right here. Our microwave extraction process, the microwaves will penetrate into the soil. It heats the soil, heats the water turns to a gas, to vapor, and will flow out of the soil to be captured in a cold trap. The big thing is, this is disruptive technology. The mining equipment and excavation equipment would not be required. Therefore, we can greatly reduce the mass brought from Earth to the moon and greatly reduce the cost of the mining process. Our process can be used in the 3 different venues of markets out there, the moon, Mars, and asteroids. The last 7 years I was at NASA, We developed this technology through laboratory experiments, numerical modeling. I presented at conferences and marketed to NASA high-level managers. We will continue this kind of marketing, but we will also market to the new space industry to cultivate strategic partners. Our short-term goal is to build prototypes, test these prototypes in a relevant environment at Marshall Space Flight Center, integrate this into a lunar rover and test it. And the goal is to develop a short-term water mining demonstration. Our primary competition is the status quo. NASA is very risk-averse and it's very expensive. We have a competent team that can move this company forward, and we're asking for strategic partners and $500,000 over 4 years. Thank you very much. Questions? Yes.
Do you need a license from the U.S. government, and what kind of? And if you've got one, what kind of license is it? If you develop this at NASA, I guess for you.
Oh, I have an exclusive license for the patent.
Thank you.
Technology.
Can you comment on once you have the water, what are the steps at that point to make the water valuable? So do you have to partner with somebody? I mean, what exactly is done with the water for your customers that you showed, the moon companies, the asteroid companies, the Mars companies?
Yeah, this is enabling technology, and we will need to partner with companies that will transport it, convert it into propellant or whatever. So it will be a network of companies that will come together to do the process. But mine is enabling technology which will greatly reduce the cost and make it more cost-effective and efficient.
And who are those other companies? Have you thought about who they might be or who you might partner with to make that water valuable for your end customer?
In the short term, I know that there's a Canadian firm that's built this rover drilling apparatus. And NASA, I believe, they're leaning towards using this company for their prospecting missions. So obviously, they're the ones to go to first to put the microwave probe into their drilling apparatus.
I just have a question. So you've got a 4-year plan, which is fine. So what's your vision of, I guess short vision, since it's only a little time, what's your vision of what the status of this project will be at year 4? In other words, where will the industry be 4 years from now?
I visualize it being like a stage 3 after the SBIR program, where NASA would then fund further development to go on to their prospecting mission. And obviously it's requiring NASA funding. But I'm hoping to get strategic partners that can also contribute to the development. Till then.
Thank you.
Thank you.
Has it gone by so fast? That's why they call it lightning pitches. Our final contestant today is Terran Sciences Group. Clock starts ticking as soon as he starts speaking. Good luck.
Hi everyone, I'm Justin from TSG. I'm here to talk about our structure fabricator. Uses a selective laser melting of regolith. Regolith, we're talking about soil, dirt, moon dust, or just dirt laying on the ground here at Earth. So essentially, we're building a giant laser 3D printer that uses dirt instead of metal or plastic powder. That means we can build up protective structures made out of solid rock using the dirt we have in front of us. Why are we doing this? Why are we motivated to do this? Basically, we want to enable spacefaring human civilization. We're mad that 2001: A Space Odyssey didn't happen in 2001. What's the main problem? Why isn't this hotel and this conference on the moon right now? Radiation will kill you. And the leading technologies to protect you from radiation are very, very expensive. Even those that use ISRU, the same dirt kind of things we're thinking about, gluing or melting them together, still cost a whole lot. So the solution, we want to improve on those. We want lower mass. We want it to be more effective than the NASA and ESA methods, which are the leading competitors now. And if we do that with infrared lasers, it provides a viable method that we can use right now. What's great is if you apply this to Earth, terrestrial application, you can break into the construction industry and get a lot of near-term profit. So about the technology, it's solid state, uses renewable power source. It's all automated. It's a giant robot with a giant laser. You can always solve problems like that. And you set it and forget it. It's autonomous. All these are proven technologies that we can put together in our garage right now. It just so happens that the arrangement we use, we hold the IP and it's protected. So the limitations with the competitors, NASA's using microwaves, high power consumption, low density product. They make little moon bricks. Regolith FDM with ESA, they actually have to bring binder with them. So they're taking glue to the moon to glue dirt together. Cost goes up with mass, so that's not very effective either. If you talk about the terrestrial application, the only thing that's a close analog is if we go head to head with heavy machinery in the construction industry. So because we don't really have any labor, material, or operations costs for our machine, 10 years of us costs $500K. 10 years of a Caterpillar bulldozer, we're talking about $3 million. So we've done some case studies. This is a simple one. This is a roadway. You can really build anything, but this is flat and simple. Order of magnitude cost reduction, all right? Nobody's using this in the construction industry, so it's like there's no similar competition, and they're burning $500 billion a year. If we can get a tiny bit of that market, it's a windfall. A little bit of risk here, yeah, because the construction industry isn't going to know about this technology, okay? They're going to think it's slow, like a 3D printer on your desktop. So what do? Technology demonstrators and trade shows. Our business model is pretty simple. We're taking it from the lab into production. In about 2 years, we can be making quite a bit. And the idea is essentially, we've already seeded. We're seeking 1.15 million of Series A. That's going to give us a year of operation. What that's going to allow us to do is get that development up into the manufacturing phase, and then that'll give us time to get our advisors and contacts networked into the construction industry, because the best way to go in construction is face-to-face or business-to-business. This is our team. I have 10 years, 3 startups behind me. The rest are a little young, so we've got quite a bit of partners and advisors that are helping us along the way. After 3 years, we're looking at 1,500% ROI, and then it goes exponential from there. So you spend a little, you make a lot. Thanks for your time.
Do you guys actually have a working engineering model in the lab? And have you done, you talked about creating a roadway and bricks and things. Have you done some of these tests?
Yeah, a lot of these have actually been, people have been fooling around with this technology for a couple of years. They just haven't used the right wavelengths and used the right lasers. We have a laser in the lab right now that we do small scale testing with. We really think this is one of those ideas where people will, when they see it, they'll hit themselves in the forehead and say, oh my gosh, I should have patented that, it's so obvious. We think it's the obvious solution. Us and other labs are replicating it right now.
And then how physically big is it in terms of mass? If this does have to go into space or get launched, is it
well,
hundreds of kilograms?
If we're going to the lunar surface or we're going to Mars, you want to keep it curiosity size, so something small that could actually rove over the layers and make the shapes. If you're doing this on Earth, you might as well make it as large as a house. That simplifies it, and then you just have a CNC gantry that operates the laser.
It sounds like initially in the first few years you'll be doing a lot of terrestrial work, so your customers will be here on Earth and in the construction industry. How do you see that transitioning to more space applications over time? So I guess I'm asking for, if your ratio is 90% ground or Earth and 10% space now, what's that ratio going to be in 5 years and in 10 years?
Well, the idea, of course, originally was to provide radiation protection. This was a space technology, and we found that it scaled and made more money terrestrially. So over the first couple years of revenue coming in, we really want to funnel that back to the R&D on the space side. So we can use what we make here on Earth to fund ventures that are going to the moon or Mars. I'd like to see it 50-50 in 10 years maybe, but it really depends on what some of those big clients like government agencies and SpaceX, those kind, when their time frames line up.
And just following that question, so on terrestrial applications, have you gotten traction with construction companies or anything on Earth now that have looked at the product, or you haven't quite gone public yet?
Well, one of the people on our board of advisors is the local ASCE president, so he's got a lot of connections in construction. And the most I've been advised to say at this point is that there's a lot of interest, okay? We do want to bring them into the lab and show them. They want to see it happen. And if so, obviously, when you look at an order of magnitude difference, it's, something they're very interested in.
Is there a strong correlation between the radiation type products and the regolith laser type product? Is there a sharing of IP?
Oh, for the methods, sort of, because you're applying, a large amount of thermal transfer to get something to sinter or melt. All right. So the idea is that the laser is a little more efficient. You use an IR laser in the, close IR range. You're right in the middle of your black body curve. You cook it a lot faster, basically. So instead of microwaving bricks, you can make a continuous structure much quicker. All right, thank you very much.
What a great group of presenters today. Let's give them all another big hand. And now I'm happy to introduce to you again Megan Crawford, who's going to take us home.
So first of all, I'd like to say thanks to Tom, our fearless leader. He's the reason that any of this exists. He just absolutely tirelessly advocates for the foundation and for this program and for the education of these entrepreneurs that are going to create the future of space. So Tom is a very important guy. If you don't know him, come introduce yourself. I know that everybody is dying to learn more about the competition and more about our competitors. We have a great website, NewSpace BPC, stands for Business Plan Competition, newspacebpc.com. You can also find us on Twitter and Facebook. We've got links to all the different competitors' web pages and their Twitter and Facebooks as well. So that's a great resource for you guys to learn some more about these guys. I also wanted to let you know that since everybody's dying to know who won, right, who gets the big fancy check and all the money, there will be a reception this evening at 6 p.m., and we will be announcing the winner of the competition shortly after that reception begins, about 6:15 or so. So don't be late. We'll look forward to seeing you all there. Thanks again to our judges, Amaresh Kalapara, Steve Goldberg, Brad Fleury. I know that they took a lot of time out of their busy days to be here, and hopefully they had a little fun with this. So thank you, everybody, for paying attention, and take a look online, learn more about these great companies. Thank you.